lecturer and has carried out research at SUNY Binghamton University, USA. Her funded projects from DST and IGCAR, her 30 plus SC.
Hello.
Hello.
Yeah, it is been muted actually.
Sorry. Someone. Can you able to hear me, ma'am?
Yeah.
Yes, ma'am.
Yes, ma'am.
Yeah. We are delighted to have her with us today to share her insights on exploratory data analysis. On behalf of the organizing committee and all participants, I extend a warm and heartfelt welcome to Dr. Brinda ma'am. Welcome, ma'am. I'm handed overing the session to Brinda ma'am. Thank you, ma'am.
Please, ma'am.
Yes, ma'am. Just wait a minute, ma'am. Let me share the PPTs.
Hope Saraswati ma'am muted all the participants. Saraswati.
Yes, ma'am.
Is that PPT visible, ma'am? I just shared it now.
Yes,
Yeah.
ma'am. It is visible.
Yeah. Yes, ma'am. So, thank you very much for giving this opportunity. It's especially a good one to meet a bunch of faculties and share my experience. It is, let me put it in that way. So, we know everything, just this type of FDPs will enlighten our knowledge further. So, that is what I feel. Thank you, Dr. Kavita ma'am. And let me proceed with the today's session of the first session will be of descriptive and inferential statistics for exploratory data analytics. So now let me start with the just a gist of definition, or you can say why this EDA. So what is EDA and why we need this EDA actually? So before going for any interpretation of, if you consider any real time data set, we always go for some of the interpretation. And with that interpretation, if you take up any business or any scientific research or anything else, so we need to analyze the data to get the interpretation. For getting the interpretation, this EDA is very much important, so that we can understand the data behavior first thing. And especially whenever you are understanding the behavior and what actually the pattern of data. See, it is not data, it is a plural one. So where we have it may be of many rows and many columns usually. So where we have to analyze the data. So such real-time data will usually have a variety of patterns, and it may be of anomaly, it may be of a good data, it may be of a structured data, or it may be of unstructured data. So understanding the data and how to process data for that understanding, with both will be included in EDA. And usually after analyzing the behavior or identifying a pattern, we have to validate the assumptions. So assumptions, in the sense, it is um, how what actually the pattern the data conveys, and how we are considering, how we are interpreting that, and how we are doing that decisions, whether to improvise the further the data quality, or based on the data what type of decision we are going to make. So for all these parts, EDA is very much important. So how we are exploring, we are going to explore the data. So explore and analyze, there are two parts. So the explore thing will be of either by statistical method or the visualization method, or combining the both, right? So first thing, let me go for a descriptive statistical method. We know very well, whenever a descriptive statistics, if you consider, we consider this mean median mode, and very importantly, when to use this mean median mode, that is very important. So whenever we know very well how to calculate these mean median mode and all, but especially when where we are going to use these content, and what is the interpretation of each and every basic statistic, basic these basic statistics convey us actually. So if you consider the mean, is, we know very well, it is sum of the all the values divided by the number of values. So it conveys the overall central value of the data set, right? Or it may be, suppose if you are considering a sample mean or the population mean. So what do you mean by population and the sample mean? Population means whenever you are considering the whole data set. Say for example, if you have a data set about the student strength, or if you are considering more than one engineering college in Tamil Nadu, and if you are considering all the whole engineering colleges, all the students, about some data about the college students in that way. So when you are considering whole data, it is population. And if you are calculating mean for any of the students, whether it may be of CGPA, grade points, or marks, or anything, so that is whole population. But if you are considering only your engineering students among all the population, then it becomes a sample. So whenever you are considering only the part of that particular data, you have to use a different algorithm, as it is given here in this way. Let me use an highlighter here. So wait a minute. Yeah. So in this way, you can use the sample mean. But when you are using, so this is the whole population, you have to use this one, right? So that is one. Just the symbols are different. That's all. Because whenever I think you have noticed it, in many times it will be X bar or mu, we will be using it. Why this difference is, X bar is for sample and mu is for population. That is the difference actually. So usually we know very well that mean is actually for numeric data, and mean distribution. So I'll discuss about distribution also. So where whenever you consider a mean in the distribution, it is actually a symmetric one, the center part of the any distribution, that. And that is, you have to use this mean only for this type of distribution. That is, when the distribution is normal, you have to go for a symmetric one. Then you may ask another question, what if the distribution is not symmetric, right? We will discuss that also. And when there is no major outliers, you can use this one. So outliers, in the sense when the data is not confined with a particular group, or the data is not reflecting the pattern of the particular group, we call it as an outlier in that case. So, and when you want a overall average, you have to use this mean actually. And we have another thing where we have this weighted arithmetic mean, right? So we will discuss about this weighted arithmetic mean and the trimmed mean also. Trimmed mean means a chopping up of the extreme values in that case, right? uh, I will we will discuss with this later on, right, with the coding and everything, right? So now let us move on to the median one. So where we know very well the middle value, if the odd number of values or average of middle values, and that is what median we call it as usually. And how to calculate the median? We usually just call the function, whether we are using a Python or R code, we usually just call the median function and calculate it. But actually how the median is calculated in this way, say if you consider this n is the total frequency, right, 3194, that then the median class. So this is what the whole n is divided into this range, frequency range, in this way, in this frequency range. And this median class is nothing but this 21 to 50. This is what the median class. So this median is estimated by interpolation for grouped data. I'm talking, this is not the normal median. Normal median is very simple. So that's why I'm just showing you how to calculate the median for grouped data. So the median class is 21 to 50. It is here, and the frequency is 1500, and that is what median class frequency we have added it here. And the lower boundary in the sense the minimum, right? So the minimum in the median class, this is 21. And the width of the class, usually width means 50 minus 21, this is what, 29. This is actually width of this class. And cumulative frequency before the median class. Before the median class means you have to sum all this one, 200 plus 450 plus 300. This is what cumulative frequency before the median, in this way. So whatever we have calculated here, it is just you have to substitute in this median one. So L1 is nothing but the lower boundary, that is 21. We have added it here, plus n by 2. N is nothing but 3194 divided by 2, that is what given here. And f is the frequency, that is frequency of this median, 1500, and that is so by 2, 1500 by 1500 f is given here in the denominator. And we have this f, this cumulative frequency 950 is added here in this way, right? And in multiplied by the width, you have to calculate the width. So if you calculate it in this way, so you will be getting this median is 33.51. So now the average, the median value of this particular group of data is 33.51. In that way you have to interpret the data. So this is not for the normal data, but this is for the grouped data, the median. So normally we know very well how to calculate the median, right? So when to use this median? So when the data is skewed, as I told you already, when we have the mean value, that is when it is normally distributed, only in that case we can use the mean value, right? And I told you that. So previous, if you just check this one, so the distribution is symmetric, that is normally distributed. In that way only you can use median. Otherwise you have to go for median, mean, right? So the median here, use the median when it is skewed. Skewed means when it is not normally distributed. We are going to see what are all the different types of skewed also. I will explain that there. So usually if you just check skewed means it may be of income. So where it may be in a lower side skewed or upper side, that is most of the skewed mean the sense most of the data will lie only in the left side of the mean or right side of the mean based on that, right? Mean and median, it will be calculated with based on that. And if you have outliers, where when the outlier are present in mean, you cannot use it, but you can use the median to interpret the data. So why we are going for mean or median? Just to interpret the data, right? So you want the typical value of without distortion. distortion in the sense without deviating from the interpretation. If you want the exact value or exact interpretation, you can go for the median one. So when the data contains extreme highs or lows, so that is what outliers we have, right? Next one is mode. When the data is categorical, of course, we know very well that whenever it is categorical, whenever we don't have any numerical value, we go for the mode one. And when we want to know the most common choice, say for example, suppose if you are offering a particular course and if you are asking the students for the options to select it, some may give the option of yes, some may give the option of no. And what is the common choice if you want to analyze? Then you will be getting this mode one, categorical, yes or no, in that way, right? So when the distribution is multimodal, so multimodal also we are going to discuss it. What about that? So now I have to explain you what is the distribution, the skewed one, the multimodal, everything in that way, right? So now coming to the distribution. So generally we know very well this distribution is what we call as Gaussian curve or bell-shaped curve, and where we have this mu, that is mean. This is what the mean. And whenever, assuming that this is a data about it's about a student's marks you are displaying, and we can say when the curve is a bell-shaped curve. So how we are getting this curve? It is actually when you have the data point in this way, right, where more of the data is around the mean. In this way, if you have more data and some of the points in this way and in this way, so very few in the tail side, both the tail side, then we call this as and the shape. So after plotting all the data, if you draw the curve over the data, you'll be getting this bell-shaped curve, or we call it as a Gaussian curve. And around the mean, so here it will be 34% of the data will be in this side, that is one standard deviation in the negative side, and again 34% of the data in the positive side. So mu plus one standard deviation, this is mu minus one standard deviation in this way. And again, so what about the rest of the data? So if you just check this one, so this data and this data will be a 2 standard deviation away from the distribution, away from the mean actually. And this data here and this data here are 3 standard deviation away from the mean. So that is what the bell shape formation. So whenever a curve data is bell shaped, that is, we call it as a normal distribution. And now if you interpret the data with mean, it will be a perfect one. Suppose if the data is not a bell shaped one, then what we are going to do, right? So that I will explore it with after 2 more slides. Now in this descriptive data statistics, we have the option of dispersion. Dispersion means the range. That is, suppose if you see one part of the distribution is whether you have to check whether the data is normally distributed or not, and then apart from that you can calculate the range also. So range means, so say for example, I have taken a sample of these data, and in this way range means it is what is the maximum minus what is the minimum, and that is what usually we called range, right? So based on this range, we can come to a conclusion whether the distribution is wide or narrow, very narrow, right? Suppose if it is it is just the for mark I have added this range distribution. So if usually the marks will be from 0 to 100, right? In that case 50 is a broad one, wide distribution only. It is not a very narrow one in that way. Suppose if it is 10 or 20, if the difference is 10 or 20, difference between the maximum and the minimum is 10 or 20, then we can say it is a narrow distribution in that way, right? So the next one is variance. So how far each data point is from the mean actually. So variance in the sense it is here if you just take this data, this particular scores data what I have. So if you want to calculate the variance for this data, then you will be calculating in this way: 45 minus what is the mean of all this data. You have to calculate the mean. So that mean, right, the whole square plus, and the next calculation is 50 minus mean, 50 minus the mean, the whole square. In this way you have to sum it up all the square, that is squared sum of mean, squared sum, and then you have to calculate the mean of that squared sum, n divided by n, that way, so that you will get the variance. So what the variance will tell you actually, so whether the variance, the data points are tightly grouped around the mean or widely spread out. So when when we get small variance, we call it as the data are tightly grouped, or when it is spread out, we can get to know that we have large dispersion. You may think that why don't we get it directly from this data? See, because here it is just 5 data, it is very easy to identify whether it is wide or narrow or something else. When you have 1,000 data, when you have 10,000 data, when you have 1 lakh data, so it is not easy to do it, easy to interpret immediately by seeing this. So we need to do this type of range variance. And the next one is standard deviation. We know very well the square root of the variance is actually the standard deviation, right? So variance usually indicated by the symbol, this small sigma, and so this is square root means then we call it as standard deviation in that way, right? So as I told you, the range is the simplest measure of dispersion with the maximum and the minimum. What is the purpose of range? So as I told, it is spread of the data, right? Whether that is wide or narrow. And um, suppose when we cannot use this ranges, when we have an outlier, that is, see, if you have a data in this way, right? So this is what the minimum and the maximum, right? So say this is actually the 45 and the maximum is 100. Suppose if you have like this, and one such data is here with 120, right? So this point will be 120 means then this will become an outlier. In that case, if you apply a range, you won't get a perfect interpretation of the data, because due to this one single point, what happened, instead of, so when you just check the range for this group, it is 100 minus 45, but when you just calculate the range for with 120, if you include this extreme data, then it will be 120 minus 45. So when you are subtracting and get the range of value, the range will be very wide, and you will end up with wrong interpretation. So that is why it is given as range is very sensitive to the outliers. It doesn't tell how the values are distributed in between. Suppose if they are outlier, if you have outliers in your data, you should not use this one, right, in that way. So that is what the purpose of range actually. So range means there is a large variation in the performance. In that way, we can get to know that. And the fifth one is about coefficient variation. That is standard deviation as a percentage of mean interpretation, right? So you can use the standard deviation. As I told you, the square root of variance is standard deviation, right? So when you have the lower coefficient, we can come to a conclusion that it is more consistent, and we have a stable data. And when you have a higher coefficient variation, then it is more relative to the variability in that way. It is not stable data in that way, right? And suppose if you check that one, when for example, if you are investing, and if you want to just to analyze the investment plan, and with the mean as 10%, standard deviation as 5%, then the coefficient variation will be 50 percentage. The same way, when you have an investment plan with 20 percentage mean and 5 percentage standard deviation, then it will be 25 percentage. So in that case, investment A is varying much, 50 percentage of variability, higher variability, but investment B is 25% variability only. So it is very investment A is very risky. You cannot, it is very unstable when compared to investment B. Then you have to go for investment B. Suppose if you have another investment, suppose if you have another investment of investment B, in that case, how to interpret? Suppose if that investment B has 10 percentage of variance, right? In that case, you have to consider it as investment C is very stable, because it is compared to B, C is 10 percentage only in that way. Sixth one is IQR and outlier deduction, right? So IQR, in the sense, we call it as excuse me, interquartile range. Interquartile range. What do you mean by interquartile? What do you mean by quartile then? Suppose if you have the whole data, if you are just considering 25 percentile of the data, then that is, we call it as Q1, and 75 percentile of the data are considered as Q3. So whenever the range, previously I explained you just the range, now it is interquartile range, means we won't get the range by maximum minus minimum. Instead, Q3 minus Q1, that is 75 percentile minus 25 percentile. In that way only the range will be calculated. Then why we are calculating this interquartile range? Because based on this range only, the outlier will be identified. You may think that don't why don't we use why don't we use a graphical representation to display the whether the data has outlier or not? Yes, you can do it. That is how much deviation it is, right? How much varied the outlier is. So numerically, if you want the data, you can identify this type of IQR calculation, whether the particular data has outlier, that is outlier is present in that data or not present, and the outlier may be at the lower end or at the higher end, right? So how we are going to calculate? Let us go for an example for this, right? So usually for representing this IQR and everything, this type of visualization we use, this is what we call box plot, where the box plot is having the properties of, usually the part of the box plot is will be having a lower fence and the upper fence, and I'll tell you how to calculate this lower and upper fence. Okay, and then we have that is whatever the data lower than the lower fence or outliers, lower outliers, and greater than the upper fence or fence or upper outliers. And IQR is nothing but this Q3 minus Q1. So that is what we call IQR. So this here this particular line indicates the median usually. So this is a normally distributed box plot. Why I am saying, but with outliers, with few outliers are there, right? In that way. So lowest value 25 percentile, this Q1 is 25 percentile, Q3 is 75 percentile. Then you may ask, what is Q2? Q2 is nothing but the median. Median is 50 percentile. So that is what Q2. And highest value is Q4 actually, right? In that way. Now, how to, by statistical way, how to identify whether the data has outlier or not? That is what we are going to see. So before exploring this, the calculation of outlier, we should know what about the distribution shape and what is skewness, kurtosis, and about that impact analysis also, right? So now what do you mean by skewness? As I told you, usually the normal distribution, in the sense it will be like in this way, where you have a curve of bell-shaped curve. Bell-shaped curve means it is normally distributed. But instead of this bell-shaped curve, if you have the skewed data where you have the tail, so if you just check the bell-shaped curve, the tail will be very less. But here the tail will be long, right, away from the y-axis, then this is positive skewness, right? Or else, if you consider the most of the data is closer to the y-axis, we call this as a positive skewness. Or in another way, it may be sometimes the tail will be closer to the y-axis. This time it is called negative skewness. So usually, to what extent we can consider the data as no skewness? So that is what given here. If the skewness value is near to 0, we consider it as without any skewness. There is no skewness at all. Or else, if the skewness is near to 0 means whether it is minus 0.5 to 0.5, then we measure it as no skewness. Suppose if it is 1.2 or minus 1.2 in this way, right? So it is in this way, that is mild. So minus 1 to plus 1, we call it as, that is 0.9, not minus 1.2, it is 0.9 or minus 0.8 in that way. Then we call it as mild skewness. So in general, you can come to a conclusion that if it is minus 1 to plus 1, we consider it as no skewness. Otherwise, if it is below this minus 1 or greater than plus 1, we call it as skewness present. And how much skewness present based on the value of the data, it differs. We will see such an example also, the skewness levels, right? The next one is, next statistical interpretation of about the distribution is kurtosis, right? We call this as kurtosis. Kurtosis in the sense it measures how much thinner or fatter the distribution is. See, previous one is whether the tail is to the away from y-axis or near to the y-axis. In that way we calculated based on the tail value. Now it is about the width and the height of the distribution. That is what kurtosis. So whether it is much thinner or fatter the distribution compared to the normal distribution, when compared to the normal bell-shaped curve, whether it is thinner or fatter, that is what we are going to decide, right? So for this, you have to calculate the excess kurtosis. So excess kurtosis is a matrix. It just compares with the normal distribution. So how to calculate the excess kurtosis? Usually kurtosis minus 3, that is what excess kurtosis, right? Say, I will tell you why 3 is used here. We will discuss at the end of this kurtosis, okay? Now, moving on to this, what we have type of kurtosis, that is thinner or fatter the distribution. Based on that, we have type of kurtosis. So first one is mesokurtic, where k equal to 3. So when you calculate the excess kurtosis, the kurtosis is 3, and then 3 minus 3, because excess kurtosis formula is kurtosis minus 3. So here the kurtosis itself 3, so 3 minus 3, 0. So when it is 0, we call it as mesokurtic, and that is nothing but the normal distribution, that is bell-shaped. We have the bell-shaped curve. So for normal distribution, the kurtosis is mesokurtic. And the next one is, when the kurtosis is 5, then what we are doing, 5 minus 3. Subtracting from 3, we are getting 2. When you get a positive value of excess kurtosis, then we call it as leptokurtic. Positive means this will be thinner, right? The distribution will be thinner, right? That is, and also it shows heavy tails on the side. Heavy tails up to this, it moving on. That is, few points are there in the lower and upper end. That is what the tail means, right? Suppose if you analyze the finance data, then where usually the leptokurtic distributions shows that the investment returns may be due to the extreme values on either side. Therefore, the investment it should that is why it follows this leptokurtic. In that case, you should not. It is a risky investment because in the lower side and upper side we have few points, and the distribution is very narrow one in that way. Then the third one is platykurtic. Platykurtic in the sense there is no tail at all, and this one is very it is not thinner, it is actually bulky one when compared to the normal distribution. So platykurtic means whatever the kurtosis is 2, 2 minus 3 minus 1. Whenever the excess kurtosis is negative, we call it as platykurtic in that way. That is, this flat tails indicate that small outliers are there because it is not a complete one. We have some more outliers are there. Say if you take the financial concept, the same here, right? Um, this type of platykurtic are more desirable by the investors because there is a very small probability that you will have this extremes, right? There is no extremes at all here, very very small probability. It will be always the predicted data you can get it. So that is what a platykurtic. Now the question is why we are subtracting with 3 always, right? So remember we have this distribution here where the normal distribution I told you, that is one standard deviation, two standard deviation, three standard deviation. Apart away from three standard deviation, whatever the data is there, those data are outliers. So that is why we are subtracting this kurtosis with from 3, actually 3 standard deviation, that way, right? So if it is not following the normal distribution, right? If it is following the normal distribution, then it is mesokurtic. So you will be getting this 0 here in that way. Now, so these are all the 3 types we saw. You can now you can see the tails. We have it's mesokurtic is normally a few data only here, but in leptokurtic we have more tails. That means more number of data. It's in the lower side and upper side. This is very risky when you consider a financial investment and all. And the platykurtic, there is no lower and upper. Always we can predict this group of data what will happen. So we can you can go with this type of investment when the data is a platykurtic, or when the rate of a particular stock market is normally in this way platykurtic distributed one, right? In that way. So this is just a comparison of mesokurtic. This is what usually the bell shaped curve, right? The meso bell. And see, if you just check this one, this thinner and taller than the mesokurtic is leptokurtic, this one. So which we have this uh, the positive one in that way, right? And where we have this platykurtic, which is lesser than, height is lesser and there is no tail at all, where the leptokurtic height is bigger than the mesokurtic and also having the tail. So this is just a comparative graph between this. Now let us consider, for example, I am just considering the interpretation of 3 variables I have taken, where we have a set of data. Don't worry about the number of data points available there, because it is given what is the minimum, maximum, Q3, Q1, and also skewness value, kurtosis values are given. So now if you want to interpret the data from this one, what about the total data? It may be of a lack of data available, or just 1,000 data available. It may be of anything, but you want to interpret from this particular values. So we have three variables, x, y, and z. So how to do this? How we are going to analyze these data, right? First, you have to calculate, so what interpretation we can get it from this type of data is. What type of interpretation? Type of interpretation in the sense, you have to calculate the IQR, then whether the outlier is present in this particular group of data or not, right? We don't know the individual data points. See, we have only the minimum maximum Q3, Q1. With this, you have to identify the outlier, right? So that is what the interpretation. So with that, when you interpret that, it is not only the outlier. From the skewness and kurtosis, we can get to know about the distribution also. So why we need to know the distribution? Because we need to say in what type, based on the distribution, you can go for mean interpretation, median interpretation, and also whether it is normally distributed means what would be the mean usually. And when it is a normally bell-shaped curve means you can say most of the data will be around the mean. 64%, 68% of the data will be around the mean. So those type of many interpretation you can get it from this type of calculation. That is why we are going for this calculation, right? So I have just taken the same data here, that is excuse me, same table here for reference, and we know very well the that is I'll take another different color for highlighting, right? Yeah. So here we know very well IQR formula is Q3 minus Q1. Then how to calculate the lower limit, right? So from this given data, you have to calculate the lower limit, right? And how at the end we are going to arrive this type of this is actually the answer data. How we are going to arrive this answer? Let me give you the calculation one after the other. So first one is we have to calculate the IQR. So IQR is, if you just check this one for variable x, IQR of x I am calculating, it is 80. 80 is Q3 and Q1 is 20. 80 minus 20, 60. And if you just calculate for y, it is 60 minus 32, 28. And for z, it is 19 minus 17, it is 2. IQR range is very less for z. You have to note it down, right? And next one. So next calculation, once you calculated this IQRS, I just listed these values here, right, as an IQR. And now next calculation is lower limit. For the calculation of lower limit, we have the formula of Q1 minus 1.5 into IQR and Q3 plus 1.5 into IQR, right? See, 1.5 is nothing but half of this, the three what I explained you, the three standard deviation in the normal distribution. That is why we are taking this 1.5 here. So Q1 minus 1.5 into IQR. So how we are going to calculate? This way. This is what the lower limit. So lower limit is first Q1. For x value, Q1 is 20 minus 1.5 into IQR. IQR for x is 60. So you have to use 60. So the lower limit is minus 70. And in the same way for y value, Q1 is 32 minus 1.5 and IQR is 28. Substitute 28 and it is minus 10. And lower limit for z is actually Q1 is 17 here minus 1.5 into 2 because the IQR value is 2 here, 2, and we have the lower limit 40. And in the similar way, we have to calculate the upper limit. So upper limit, in the sense, you have to use this Q3. So the formula here we have is Q3 plus, so upper limit is you have to add it from Q3, that is above Q3. So that is what you are calculating. So that is why Q3 plus. So Q3 plus 1.5 into IQR. So Q3 is 80 for X plus 1.5 into 60. 60 is nothing but the IQR here. So we have 170 as upper limit. And for Y we have Q3 is 60 plus 1.5 into 28. So the value here is 1 or 2. And then you have the upper limit Z is actually, this is 19. So Q3 is 19 here plus 1.5 into 2, because IQR here is 2, that is 22. So all these values are upper limit, lower upper limit, upper limit are included in the table. Now we need to check for the status, that is status of outlier. Using this lower limit and upper limit only, we are going to analyze the outlier status. So how we are going to analyze the outlier status? So we have a condition for lower outlier. If the minimum is less than the lower limit, then lower level outlier is present, else no outlier. So what do you mean by minimum here? If you just check the minimum, right, and the same way we will apply this lower outlier for the 3 variables, and the upper outlier in the same way. If the maximum is greater than the upper limit, then upper outlier present, else no upper outlier. We will see for X what is the upper conditions, right? See, minimum for this X is minus 80, that is what given here. And what is the lower limit? It is minus 70, right? So minus 80 is less than 70. Then if it is less than 70, this is the condition. If it is less than 70, then lower present. That is why, so lower outlier present. We have the conclusion. And in the similar way, how to calculate it for Y? So minimum is 9 here. So 9 is not less than minus 10. So there is, so it will go for the else case, no outlier. And in the similar way, if you just check Z, then it is 10 less than 14, right? Where? Because minimum is 10 here and the lower limit here is 14. So 10 less than 14, so lower level present in that way. So in the similar way, if you just calculate the upper limit conditions for the X, what is the maximum value? 147. 147 and the upper limit is 170. So 147 is not greater than 170. So no upper limit present, upper layer. So that is why here we have no, option no is loaded here. The same way, if you just check with variable Y, we have maximum is 185 and what is the upper limit here? 102 greater than. So upper outlier present in this way. You can have S here, S present. And in the same way, if you just check the final one, the Z value 1500, this is the maximum and greater than 22. So upper outlier present in that way. So up to this we have calculated. Now confirmed that what are all the data has outliers and in which side the outlier is. It is not only just outlier, on which side you can get to know about this one, upper side or lower side, based on that. So all the 3 data has outliers, but if you just check, X has lower only and Y has upper only, but Z has, in both the ways we have outliers. Then next one is skewness status. So we have the skewness 3.8, 0.66 and 110. 3 values or 3 variables, right? So 3.8 means, I told you already. So what is the if you just remember the skewness value, if it is in between -1 to 1, there is no skewness usually, but it is 3.8, so it is positive skewness. That is why we have this positive. But here if you just check the next one, it is 0.66. Usually it is mild, we can say, but since it is near to 0, it is, we can say it is, there is no skewness at all. And the Z is 110, obviously it is a positive skewness, which is greater than 1. Now, you have to go for the kurtosis value. What is the kurtosis given here? For X is 12, and you have to calculate the excess kurtosis here, and this column actually displays the excess kurtosis, where 12 minus 3, 9 is the value. And the next one is it is the 0.055 is rounded here, and so I'm just using 0.06 minus 3 minus 2.94. It is negative, right? And when it is positive, we know very well it is leptokurtic. That is, excess kurtosis status or type of kurtosis is leptokurtic. When it is negative, we call it as platykurtic, right? Because it is minus 2.9794. So it is platykurtic. And the third one is, actually it is 900 here. So 900 minus 3, we have a positive one. So it is again leptokurtic in this way. So now, with the skewness, if you just check this one, so you may have this one, see, there is no skewness, but there is one outlier present here in the y-axis. That is the interpretation. And it is platykurtic. That is, kurtosis platykurtic, right? So in that way, so we can say, if you get any financial one, it is a y-axis is y variable is a very good one in that way. And if you just check x variable, we have a positive skewness and also leptokurtic. We know very well now the skewed one is positive. Positive means the tail will be above y-axis, or the distribution, the curve will be near to, is closer to the y-axis. That is what leptokurtic in that is, so the skewness is a positive skewness in that way. And excess the kurtosis is leptokurtic. It is a positive one. It is not a platy one. That is, the tail will be more that way, and the height is also greater than the normal distribution. That is what excess kurtosis status, right? So now, moving on to the inferential statistics. So inferential statistics, I already told you about the sample and population, and now we will see some of the other inferential statistics, where we have the sampling error, confidence interval, and p-value meaning. And most of us use this p-value in research papers. And if you just check, even if you mostly if you just check any biomedical paper, you would have noticed this p-value, usually p significance, p-value in that way. We will see what is that. And also some of the test statistics. Very few, not all the statistics I'm going to cover here. So just a few test statistics we'll see today. And also type 1, type 2 errors are we are going to explore, right? So first one, sample versus population. As I told you already, the entire group, if you want to study or make a conclusion, then it can be large, or if you consider, even if you consider all the real numbers, we call it as a population in that way. And all citizen in the data, all patient in the hospital, all, like, in that way, if you consider the whole population, or it may be sometimes a sample. Sample means a small but subset selected from the population. Where, as I told you, it's, suppose if you consider, instead of considering all engineering students, suppose if you consider only your college students, then it will be a sample. So it is used for studying the particular distribution when the whole population is impossible or costly or time consuming. In this example of engineering college students, we don't know the mark or status of other colleges, so you are just considering only your college students in that case. So in that case only we go for a sample one, right? And it is usually for survey on study, we usually use this samples one. usually sample will give you interpretation about the population. And sampling error, if you consider, what do you mean by sampling error? Since we are not considering the whole population, we are just considering only the um, uh, part of it, there will be always a difference or deviation from the original true population, the interpretation of true population and the sample population. So that is what we called as sampling error, or sample statistic minus the population parameter. That is what sampling error. So for example, if your true average income, that is the population income, is 50,000, but sample mean for 200 people. Say for example, if a company wants to check the average income, say it's a cosmetic company, if the company wants to check all the employees detail, and if the similar cosmetic companies, the company doesn't know what would be the salary, and they just know the average only, so they are fixing this average 50,000, and the sample mean from 200 is 52, right? So now 52 minus 50, 2000 is the sampling error. Just what is the original mean value, what is the sample mean value, the difference is sampling error. So why it is happening it actually? Because the sample population will not always reflect the population data, and different samples can give different results usually. That is why it happens. Say, instead of considering your college students, suppose if you are considering some other college students, again the sampling will differ, right? It may be of a different marks, average mark you will get in that way. So that is why the sampling error usually happen. But sampling error is natural, and you can accept it, because uh, it is a rough interpretation about the population when you can't go for a whole population, but still it interprets something about the data. That is why, so we can't take it as incorrect data, incorrect interpretation, but you can still consider it as an uncertainty. Can that is 2000 is the uncertainty for this, in this example, in this way, right? So the next one is confident interval, or the range of value usually, right? Suppose if you are doing the sampling for assuming that you have a 10 lakh data, and for a sample, if you are considering first time you are considering 1000 data randomly, and again next time you are considering another 1000, either it is randomly or taking as different set of batch of data, it may be anything in that way. If you repeat the samples many times, right, and 95 percentage of calculated intervals will contain the true population means. So that is why, that is what we call always 95 percentage of interval. That means, for example, if you consider the sample mean is 60 and the margin error is 5, then we can say it is 95 percentage. That means the error may be in between 55 to 65, that way, the interval. Say if you consider this particular sampling error, we got 2000. In this way, say if the range is 10,000, right, in this way, right, that means it may be some for some other sample mean it may be 3000, for some other it may be 1000. In that way it differs. So 95 percentage of confident interval, we can say 55 to 65 in that way. It is plus or minus, you can say. From sample mean, it may be this particular sample mean is 60. So another sample mean, it may be in between any of the value of plus minus to plus 5 to minus 5. So we are 95 percentage confident that the population mean lies between 55 and 65 in this way. Then why is the confident interval is very important? Because confident interval, it says it includes the sampling error, so it may be in between, approximately, we can say in that way. So it indicates some precision. That is, you have the confidence that it won't go beyond this range, right? That is why this confident interval is very much important. So whenever you are going for sampling, you have to tell the interval also, plus or minus this. That is what, right? So narrow CI, when you have a very narrow confident interval, we can say precise estimate. Say, suppose if you have this 55 instead of 55 to 65, suppose what if you have just 50 to 60, sorry, 58 to 60, it is only the difference is very two only, it's not much, right? In that way we can say precise estimate. So but when you go for a wide confidence interval, you will have more uncertainty. You can't believe that, that means the sample error is more. That is what another interpretation you can have, right? The next one is p value meaning, right? See here, the p measures, usually p means the probability, evidence against the null hypothesis in a hypothesis testing. First one, you should know what is the hypothesis testing, where um, usually the null hypothesis or the assumption, basic assumption, is what we call it as H naught, right? That means usually when there if you are analyzing a method, say suppose if you are giving a particular medicine to particular group, and another group doesn't consume that medicine, when the method is actually when so the group which actually takes the medicine has no effect. So in that way, if you have the assumption, then that assumption is H naught, that is there is no effect. There is no effect on what you are going to test. That is what test hypothesis usually. So when p is less than 0.05, that is why if you just check any research article or anything, the p significance value will be 0.05. And there is no hard and fast rules, but we don't know why they have set it like that, but it is in that way. It is 0.05. When the p significance is less than 0.05, you can reject the H naught, and you can come to a conclusion that whatever you have assumed, that the drug has an effect, and reject the null hypothesis, because what the null hypothesis we have set, there is no effect in the drug, right? And instead you have to go for the alternate hypothesis H1, and this accept or reject is calculated based on this p significant value. But when the p significance is greater than 0.05, it is not significant, right? That your drug is not working good on the patient. So that is what the conclusion, right? So it tells you, it conveys the probability of your observed results, right? Whether the null hypothesis is true or not true, right? So for example, I have another example here. Testing if a new teaching method improves the mark. A new method has no effect on the marks, that is what H naught, because no change. Usually for you can take any statistical testing, H naught will be no effect assumption, and H1 will be effect assumption. Yes, your test is correct in that way. That is how we are setting it. And the H naught is what we call null hypothesis. So, and for this particular example, the p value is 0.02. So only 2% chance of such improvement by the random choice if the old method has no effect. In that way, we reject the null hypothesis because it is less than p value is less than 0.05. So we reject the null hypothesis and conclude that new method likely to work. So how we decide? Because of this p value, probability value says that it is a random chance of only 2% without any effect. Otherwise, 98% there is an effect in the new method. That is what the interpretation. Is that clear? And now, in the same way, if you just go for these are all how we are actually come to a conclusion of any statistical testing. Now, test statistics, here we have some of the test statistics. You would have already used these statistics for t-test, z-test, and f statistics, chi-square test and all. And what is the purpose of this one? So it is just to analyze or just to extract or just to interpret how unusual the observed data if H naught is true. H naught is true means when there is no effect on your assumption, if effect on your test. That is what we are going to do. So whenever you have large test statistic, a strong evidence will have against the H naught. Usually for any statistical testing, it is better to go with large data set. Large data set in the sense, based on what type of data are you using, in that way at least 100 data you have to take, in that way come to a conclusion. A small test statistics, it is likely to match H naught. You won't get much difference. You won't get significance, p significance lesser than 0.05. That is why they insist, the researchers insist us to go with a larger data set. The sixth one is type 1 and type 2 errors. So we know very well this is actually a confusion matrix what I have given here. When H naught is true, right, and we have the decision is do not reject H naught, that is the correct decision. Suppose when H naught is false, in that way also if you reject, then it is type 2 error, right? And when H naught is true and you reject it, H naught, when it is true you should not reject, right? Just still if you reject it, then it is false alarm on type 1 error. And when H naught is false, reject, that is what correct decision. So we know very well, the usually for confusion matrix, these two will be an error and these two will be a correct one. The same one we are using it here, and we call this type 1 error as false positive, and type 2 error is false negative or false alarm error usually, right? And the significance level, say if you are teaching method improves the marks actually, and but you are still if you reject it, then in that way, so we have the false one in, right? And right, the next test is chi-square test usually. And this chi-square test, what we have here is it is about, usually chi-square test can be applied for categorical values, categorical data columns, and you should have the count of the categorical data, and you have to form this contingency table. This table is what we call contingency table. This contingency table, we have here, you have one column, one data like fiction, science fiction. So what is the relationship? Is there any relationship? Those who like science fiction and playing chess, and those who does not like science fiction and does not play chess, in that way we are just come to a conclusion. So in general, in one statement, if you just say, is there any relationship between the science fiction studying, reading a science fiction story and playing a chess? That is what the question. So how to calculate this? How to calculate this type of analysis? So you will be having a data of those, how many, two columns, um, play chess, yes or no, you will be having, and also reading science fiction, yes or no, you'll be having. Just count the yes or no here and fill it up. So how we are going to fill it up here is, you just calculate this. This is what the count is directly given here, 250. is actually like science fiction and play chess, and 200 likes science fiction, not play chess in that way. This is what the original value from the data, right? So this formula, I'm going to apply it here so that you can get this the count, right, in this way. And you have the sum of row value, that is 250 plus 200 450, 50 plus 1000 and the sum of column 250 plus 50 300, 200 plus 1000 1200, and the summation of this column sum, the 1000. If you just calculate both, it will be 1500 only in that way, right? Now applying this here, so denominator will be the whole the total summation, grand total, that is 1500. What will be the numerator? Means, suppose if you want to check um, expected count of, how many of them expected count are like science fiction play chess. So how to get it? Like science fiction, the sum is 450, here 450, and the column play chess you have 300, 300, 450 into 300 divided by 1500, 90. That is what given here in the bracket, 90. In the similar way, if you just check, for example, not science fiction, not playing chess, if you just check this one. So this is 1050 into 1200 divided by 500, it is 840. Now this, all these four values are to be substituted in this chi-square value, so that how we are getting it, each and every chi-square value. This is 250 minus 90. What is 250? It is what already observed in the data. 90 is the calculated data, divided by 90. In that way, you just go for the next one. This is 50 minus 210 divided by 210, and 200 minus 360 divided by 360, and then 1000 minus 840 divided by 840, in that way. So what we have here is the chi-square value is 507.93, and the p-value, p significance, what we get. See, if you just apply this, the probability value, no need to worry about how the p-value is calculated. It is just the probability. With the given data, the probability can be calculated. If you apply any chi-square test formula, if it is even in Python or R, you will along with this chi-square value of 507, you will get this p-value also, right? So here the p-value is less than 0.05, so we reject the null hypothesis. And here if you just check the p significant, it is 0.00001%, right? That means that is the only probability that it is like science fiction and play chess are correlated. It is not correlated is only this percentage. Otherwise, it is highly correlated. Those who are reading the science fiction and playing chess in that way. So it shows their IQ, general knowledge, or the interest in that way, right? So this is what chi-square test, and this is how you have to interpret. And then the next one is t-test, where the t-test is a, you know very well, it's again a statistical test, right, where two averages are truly different from others, that is mean between the groups, where chi-square is only for one, and here between the groups. Say for example, do the students taught the method A scorer higher than the B method B? If you are using a chalk and talk method, how they are scoring, or if you use PPT, how they are scoring, is there any difference in that way? So another example is the average of a sample different from 7 kg, or do the male and female employees have different mean salary, in that way, right? So we have some of this example where we are going to apply this t-test and get the interpretation. So generally we measure the small sample, but usually we want to conclude about the population. So this t-test helps to bridge us the gap, so between the sample and the population usually. So sample mean and standard deviation and size, and these are all used in a t-test. This allows us to judge the difference, the statistically valid or not, the t-test is valid or not. As usual, we will be using this p significant. We can reject the null hypothesis and measure the risk based on that. So we have a type of t-test where we have one sample t-test and independent two sample t-test and mean group of usually one sample means it will be a mean versus known population only. And two sample means it will be group 1 and group 2. Two samples will be considered. And paired means it is before and after. Suppose what is the difference between the same group? What is the how they behave before giving the drug and after giving the drug in that way? That is what paired t-test. Right. So in the next session, let me explain you the how this the box plot, we can go with the graphical representation, the heat map, and the same box plot you can explore it as a violin plot also, or the pair plot. In that way, how the distribution can be given as a pair plot. And usually in summary you'll have a minimum, maximum, and mean, median in summary, and those type of results also we will see in the next session, right? So in this particular session, we have the descriptive, that is understand the sample, inferential, generalize the findings, and usually for both descriptive and inferential are needed for any statistical interpretation. Thank you. Any questions? So,
Participants, any questions?
Thank you, madam. Thank you very much for giving wonderful presentation. Here I have a doubt, which is the best method for testing of this using Python or SPSS, ma'am?
sir, SPSS is just a drag and drop tool. You have to purchase and use it to some versions are there, but it is better to go for, if you are going for research purposes, R is better because R has, even if you just check with chi-square test or t-test, R has more number of options, are different. For chi-square itself, there are 3 or 4 functions are there. So that is what R providing you. R is good for explore EDA and also data analytics, statistical analysis. But still, we are widely using Python. Nowadays, we have the Python packages, all the packages, whatever are available, it is also available in Python. So it is anything R or Python, you can use it. It is better to use these two instead of SPSS for research purposes.
Thank you, madam. Thank you.
Yes, good evening, madam. This is
Yes.
Chandla from Hyderabad, madam.
Yes.
Compared to R, that Power BI is good, ma'am. Tool for
Sir?
that Power BI will be there, no, ma'am.
Yes, sir. Sir.
R that will be good, ma'am.
But that sometimes some analysis it's not possible there with that one, but all the statistical analysis and interpretation, how we can interpret all possible with the help option, it is available in R. So R is better than that, you can say. Yeah.
Shall we resume the session after 10 minutes break?
Yes, ma'am. Yes, ma'am.
Is it okay for you,
Yeah,
ma'am? Need at least 10
need
minutes.
yeah, 10 minutes. After 10 minutes, I can resume.
Okay.
Excuse me,
Thank
ma'am.
you.
Excuse me, ma'am.
Yes, ma'am. Yeah, yes, ma'am. Yes, ma'am.
I'm Rajni and I'm from the Delhi. Actually,
Yes.
you said that that Power BI has a limitations, but I don't think so. That Power BI also have a integration with the Python and R, so we can use it for hypothesis?
Sir, ma'am, Power BI is a visualization only. You can't have the statistical values in Power BI. Statistical analysis and formula you cannot have. Power BI
లేదు
is
అసలు ఏం తినకుండా పడుకుంది అవి తాగేది ఇది ఒకటే
Power BI is just the visualization tool, ma'am. It's not the statistical analysis tool.
ఎవరు
Ma'am, we can here integrate with the Python and R also, and here we can already analyze it and use it as a statistic.
ఇప్పుడే అవుతుందా
Yeah, that integrate and use it. But separately, if you ask which is better, which R gives both, and Power BI cannot. You have to integrate only. After integration only, you can use it.
ఇప్పుడు అసలు కాలేజీకి వెళ్ళి చెరుకోపి లేదు
Okay, ma'am. Thank you.
పెట్టింది ఒక
అవును ముస్లిమ్స్
అంగపైన నాకు తెలిసిన అక్క గుర్తిద్దిగా
Managers, please mute remaining participants.
ఎఫ్డిపి గ్రూప్ కాల్ కాదులే కానీ అలాంటి జూమ్ మీటింగ్
Ma'am, shall we resume after 10 minutes, please?
మ్యామ్ యా హలో హలో మ్యామ్ హలో నీ మాట హత సుధా నీకు Saraswati ma'am? Yeah.
Yes, ma'am. Am I audible?
Yeah, yes, ma'am.
Yeah, thank you. Wait a minute.
No problem.
Okay. Shall we start the session now?
Yeah, yes, ma'am.
Yeah.
The screen is visible.
Yes, ma'am. Thank you. So now this, I think echo ಅಡಿಕೊಂಡು. Ma'am, it is being echoed, right? Okay, now it's clear. Am I audible now?
Yes, ma'am.
Okay. Yeah. So in this session, we can say it's a continuation of what we explored earlier. Even to complete all the part of what I have planned, I just cut short the introduction part there, so that we can have more time in visualization part actually. And in the similar way here, we have the data visualization techniques, and especially for research purposes, histogram, box plot, heat maps are often used. But apart from this, we are going to check with also the bar plot, and we know very well that how to use this histogram, or how to interpret it, and or the box plot or the heat map instead. So now what I am going to cover this including this histogram, box plot and heat map, in general, how to do the analytical interaction and navigation with the graphs. That is what I'm going to cover based on this histogram, box plot, heat map, and not and also bar plot and some other line plot, and even time series plot also. It is included in this session actually. So what are all the ways of interacting with the data? If you just check the ways, right? Ways in the sense, wait, is this the presentation mode is shared or normal mode?
Yeah, presentation mode is fine, ma'am.
Okay. So what way of in what ways we can interact with the data? This we have. So this, if you follow this type of producing the data or using the data in the graph, right, then you will get a rich graph. But what do you mean by a rich graph? It is not that whenever you are using a colorful multicolor graph or a 3D graph, or more information that is loading with more information in single graph, that is not actually a rich and elegant graph. But any rich and elegant graph should provide you an instant interpretation, a clear interpretation, and the original interpretation of data. In that way, you have to do the visualization. That is what an effective visualization you can see. Say clearly, accurately, the information should be presented as a graph, right? In that way, as a visualization. So the user should have the capability to interact with the graph, and that interaction should give a correct interpretation about the data through the graph, right? So for this, I'm going to explore all these points: comparing, sorting, adding variables, filtering, highlighting, aggregating, re-expressing, all this one with small example of graphs. That's it, right? So whenever you are going for comparison, right? Say this particular graph has actually the y-axis and x-axis, I have used this horizontal graph instead of a vertical one. And here in y-axis I have a salesperson names, and x-axis the sales in USD is displayed here, right? So whenever you are going such comparison, you are just this, yes, of course this graph is providing a comparative information where Mr. Lee provided the highest sales around $1 lakh, around $1 lakh, that is exceeding $1 lakh, and you can say the Mr. Knox is the lowest performer, because that is what you can compare. And who else are having in the middle in that way? That's all. But how much greater compared to what? Usually for comparison, we have comparison in the sense a similarity or the difference. That is how we are going to compare. That is what the usual comparison is. So the comparison types are how, what are all the types of the magnitude of comparison, how we are going to compare. Whenever you have a nominal type, nominal in the sense we know very well what are all the different kind of data we have available. Nominal, ordinal, in that way. Ordinal means where there is an order in the data. Suppose if I say the height of the students or high, low, medium, that is an order, right? Which is, we know very well, low is the lowest one, and then the medium, then the topmost is the highest one. And nominal means there is no order in the data. Say if you just check this particular graph, there is no order here, right? It is north, south, east, west. There is no order at all. We can't say east is the highest one, or north is the lowest. Not in that way. So we cannot have the order or the levels in the data. So that is what the type of nominal data. So whenever you are comparing the value, there is no particular order. So the order may be anything: north, south, east, west, or west, east, north, south. Any order you can do it. That is what the first one. Second type is ranking type of comparison. How we are going for the ranking type? Ranking mean comparing the values that are arranged by magnitude from low to high or high to low, that way. See, if you just check here, on y-axis I have manufacturing, sales, R&D, and management, and x-axis I have the number of employees by the department. See, manufacturing is the highest one. See here, ranking. So which department is highest, in that way. So in descending order I have ranked it in this way. This is what type of ranking. Here you can't do any department. If you do any department in any order, it won't be of giving a perfect interpretation, right? In that way. What is the third one is here, part to whole. Immediately when I said part to whole, you may be thinking about the pie chart, pie graph, right? It is not only the pie graph that can explain the part to whole, but also the bar graph can explain it, right? Bar graph means, see, if you consider any histogram, usually histogram in the sense x-axis will be any of the particular data it indicates, that is the range it indicates, or the bins it indicates, and y-axis is the frequency. The y-axis may be percentage also. It's not necessarily it should be frequency in that way. So a similar kind of way here, y-axis, here I have the percentage, And the x-axis I have, it is the total sales by the region. What about UK, France, Germany, Italy, right? If you just check here, part to whole, if you just add all this percentage, you will have 100% here. So in this 100%, what is the part of Italy? So it is just 18%, the lowest one. Or UK, the highest 32% in that way, if you say. So comparing the values when combined make a part as a whole in this way. So only 4 regions the particular company has. So in the 4 region, each region individually you can have the percentage of sales, and also in total if you just cumulate it will be in percentage. See, this can also be represented in original USD rupees or something else, right? But if it represented by percentage, you will have a clear interpretation in that way, right? So the next one is about deviation. See, deviation in the sense, it is comparing the difference between two sets of values. So usually whenever you are comparing the budget versus actual, you have to go for this deviation plot, where the budget will be considered as 0. 0 means it is not you have 0 budget for that particular expense, not in that way. Instead, the salesperson, say for example, if the salesperson expense for each and every month is provided in that way, or each and every quarter or 6 months it is provided, it is 1 lakh expenses. So the 1 lakh will be considered as 0. From 0, if you just check Mr. Hill, what is the percentage, that is what is the deviation from 1 lakh? His expenses in positive way, that means he spent more than 1 lakh. How much? 4,000 he spent. And in the same way, Smith spent 2,000 above 1 lakh, above the budget. But if you just check Green and Bradley, Green uses only 9, it is less than, that is, it is less than 1 lakh, right? It is mildly around 1 lakh, but less than some 90,000 in that he used. Actually, his expenses. But Mr. Bradley, it is from the budget. See, what is the deviation he has? It is 7,000 amount. See, since it is a negative, it is not that you cannot interpret immediately negative, because it is expense. Here negative is good, right? Because whatever the budget, from that they didn't use the whole thing, they used less for the expense, so it is a profit for the company. In that way you have to interpret. The next one is it is a time series type, where it's usually x-axis will have a time starting from the lower end to the upper one. Say if it is hours, means 0 hours it starts. If it's months, means from January it starts. Here it is in quarter. So each quarter contains, it's 4 quarter in a year, each quarter contains 3 months in that way. See, quarterly web traffic, that is visits in millions. In the y-axis provides the visit in millions in this way. See, first quarter it is lower, second quarter, third quarter, in that way. So this is what time series of comparison usually. So when we have to use this line graph, whenever you are going for time series, why only for time series? So why not the same way, the same graph, why don't we use it as a bar graph in this way? Yes, bar graph will also give the same interpretation. Then why line graph? You may ask this question, right? So why we are going for line graph means because the time series means there is a connection between the first graph, first quarter, and the second quarter. So to represent that, we are using this line graph. So whenever time series, go for line graphs, right? Compare the patterns. Now coming to the next, it's not a type, just comparing a pattern. Say for example, I have taken here a time series data where it starts from January and ends with December. It is about the sales of international sales and the domestic sales. If you just see the trend and seasonal one, you can see the trend. It is international is more or less very flat, and only in August we have a downtrend, and then the same way there is no trend at all. But if you just check the domestic one, it is little bit increasing in trend. So if time permits, I will cover some of the times there is trend analysis also. In that way, in that I will explain more what is the trend actually. So trend means the trend line, it will be upper or lower. So it is little bit in the increasing trend, we have the domestic sales. So that is how we can compare it, right? International compare. But if you go for another type of patterns where patterns are meaningful in what type of data or what type of interpretation you are using, based on that the understanding will be different, right? See, the same data, so both the graph represent the same data, but if I use the dot plot, scatter plot, right? So this immediately I can check with this whether this is what is the correlation between the price and the unit sold. So whenever the price is increasing, unit sold is decreasing. It is a negative correlation. So from scatter plot, immediate interpretation of any user is this is what. So if you want to represent about the relationship between x and y, you have to go for the correlation plot, or the that is, if you want to represent the correlation, it is obviously the scatter plot along with the trend line in this way, the correlation line in this way you can represent, right? The same data, suppose if you represent it as a histogram, right, where histogram is usually will have a range or the bin, say this is the first bin 0 to 500, then the second bin 500 to 1000, that is 501 to 1000, then 1001 to 1500, then 1501 to 2000, then 2000. That way bins will be there. What about y-axis? Usually histogram means in y-axis the number of, that is, it may be some amount or the frequency or something else. Here what they have mentioned is units sold. How many units sold? It's count, right? So if you just check this one, here the same data, if you represent scatter plot, the user will go for correlation between x and y. But if you represent it as a bins, then the user will go for the interpretation of which particular bin has more frequency. Say 500 to 1000 television sales by price. If you fix the price, the price fixing between 500 to 1000, that sales is higher, right? So when it is 0 to 500, most of the people think that it is not a quality one, so less purchase that way. So whenever the sales is increasing, if you just check, so here when the price increasing, the sales decreasing only you can know, but which particular range is actually providing the higher number of sales, that is known by this histogram graph, right? So now if I ask you a question, which graph will be a good one, so we have to go with the both the graph, right? Because this provides whenever price decreasing, the sales price increasing, sales decreasing, right? So we will come to a conclusion, okay, we have to strict on a particular price so that the sales, and what is the price we have to fix, say this 500 to 1000 higher range, but here in the 1000 to 1500 it is lower actually. So if I fix near to 500, I will be getting a loss. So it will be around 900 or something else. If I fix, I will get more sales. In that way we can come to a conclusion. So for this interpretation, we need both the graph. And this one is about 3D graph. See, it's a very good graph. You may think that, and the y-axis contains USD, and here in this particular x-axis we have what of the type of cool drink. They have energy drink, cola or water or grape juice, crab juice or something else. And then in z-axis we have the regions. So it's a 3D plot. You may think that it is very good, but actually we should not use unnecessarily the 3D plot here. Suppose if I ask you what is the cola sales on east and west, if it is interactive plot, you can just drag this and view and that and then check this one, because if you just check this one here, east and west is here, so here it will be of cola sales, but we don't know what is the cola sales there, right? So the richness is not in what type of graph you are using. The richness is what actually the information it is providing. The information should not hidden through the graph, it should be visualized, right, in that way. So it should be you have to use the comparison for richness only, you should not use for this type of graph actually. And this one again, this is about the region, monthly sales by region. This is also a 3D graph where we have Z axis, we have the region, and X axis we have January to December, and the sales in Y axis, right? Now, which line, which color is representing which region? You may think that if you add a legend, it will be easy. Yes, if you add a legend, it will be easy. But again, it will be a confusing one. We cannot identify perfectly of which region it is. You have to use each and end of the line, you have to use the region, right? That way. Or otherwise, you have to add the filter way, filter and analysis. What do you mean by filter and view? We are going to see about that. How to make. So if you come to a conclusion, I have to use the same graph, I like this graph, then how to make it more interpretable? So through interactive graph and by adding the legend, you can do it, right? Then when you have X and Y axis only, and why you need another dimension in the graph? That is what the question usually whenever you are going for the 3D graphs. Unnecessary to have a 3D graph. If the 3D graph is not representing the correctly but hiding your data, don't use it. If you just check this one, see north, south, east, west, we have the sales and expense. For sales, I have one bar, expense, I have another bar, right? If I use this way, in the second way, if you have this one, so it actually confuses. If whenever you are using this 3D graph, how to represent this, whether it is 4.5 or 5, how to know this one? This will be a confusing one, right? Because this edges, whenever you have this height, it actually misinterpret the data. And then right, so now if you just this is again another data, which is water survey question. Are you happy with the state of economy? And y-axis gives the number of waters, and we have the bins of yes bin. This is again another histogram, we can say yes bin, no bin, and undecided bin, right? If you just check this one, you may think that immediately yes, because we have 2400 is the highest bar here, and this yes is actually a greater one, so they are satisfied with the economy. No, that is actually a wrong interpretation, because if you just check the graph starting point, it is 2000. What is the, this is 2400. If you start the same graph with 0 in this way, see the same graph, i have started with 0, and what is the yes option here? It is 2400. No option as given in here in this graph 2100, and here also I marked it as 2100, and undecided it is less than 2000. It is just in that way, so I have marked it as with the 2000 here. Now what is the difference? See the difference here, see how much difference it is. You may immediately conclude that yes, the people are very happy with the state economy, but it is more or less equal with yes and no if you just interpret it correctly. So when the deviations are, so now the question is when to start with 0, when to start with the particular other range, non-zero values. So when the difference is very less between the bins, you have to start with 0. That's a simple one, right? Okay, next one, sorting. So you may think that what is sorting, why it is marked as 2. It is just I want you just to remember, it is only the comparing I have concluded completed. Now we are moving on to the sorting, right? How analytically interpreting it in that way. So You know very well that if you just check this one, there's millions of US dollars in x-axis, and y-axis we have the states of different states of California, Colorado, Florida, Illinois, and that way. But immediately you can't interpret anything from that except Washington is the highest one. Okay, that's all. Then what about others? So always go whenever you are having this horizontal and comparing chart, sorting is a very important one. So if you sort the same graph in this way, it is easy to interpret, and always start with the highest one in graph. Highest one will be in the top. That will be better. Or if you preferably in descending order, ascending order, anything you can prefer, but it should be in a sorted way, that way. Now you can get an interpretation of Washington is the highest one and Mississippi is the lowest one. And even you can check with Colorado, California and Texas are more or less equal, and Tennessee, Minnesota, Mississippi are equal. In that way you can compare, you can have more interpretation. But whereas in this one we can't get such interpretation, right? Right. So whenever it is sorting, it is not only starting here. If you just check, it is a single y-axis, but I have used two x-axis. What do you mean by two x-axis? See, if you just check Washington, I'm just comparing here. Washington employees, this particular graph, employee compensation per state. Here employees per state, right? Employees per state. If I just check this one, why I am using both the graph in single? Because both are related to the same state. One column is about compensation and one column is about how many employees. If you just check this particular graph, here was Washington compensation and here Washington compensation, in that way. But if you just check this California and Texas, right, more or less same compensation is given by both the state. But here if you just check this one, the employees per state, California is having less employee, but Texas has more employees, but amount shared are same. So this is not a good one, right? You are giving some amount, a bulk of amount to Texas and California, but in California number of employees are less, but Texas number of employees are more. So how it will be sufficient for all the employees, right? So if you just use this graph, a different one, you won't find this particular interpretation, and you won't decide, okay, Texas need more money, more amount, right? In that way. So it is better to have, whenever a relative data are used, better to have like this same x-axis or same y-axis, then go for the representation. Third one, adding variables, right? The same way, horizontal way you are using it, right? And here if you just check the left side, we have revenue per product, okay? And here the paper has more revenue, pens have less, pencils, and then the last one, paste. So what do you think from, if you just compare only this particular graph, you may come to a conclusion, okay, paper has more revenue, I'm getting more revenue from paper, then go for the production of paper or selling of paper in that way. But if you add one more related item, adding a variable, that is what the title we are going to explore, adding one more variable as profit, revenue, profit, right? So, but if you just check the paper, though the revenue is more, but profit is, see, this more or less equal to pen, right? Now, if you just check for pencil, it is very less and it is giving more or less equivalent to pens, in that way. So if you just compare, if you go with the second graph, you won't go for the that is selling or production of paper. Instead of, you can go for the pencils then, right, where the revenue and profit. So revenue, where paper is revenue is more, but profit is very less. So that is what, as I said, related, whenever you are using analyzing it, it's better to have related items together in a graph. And analyzing add or remove type. So this is usually whenever you go for Power BI or Tableau software, or if you go with any software companies, they will have their own EDA softwares available, where you can add, and the plots will provide you, the software will provide you, just by click you can add the particular data and you can change the data graph in that way, right? So if you just check this particular graph, we have added a y-axis, one more y-axis there, product type espresso, then product, that way, where espresso have coffee mocha and decaf espresso, coffee latte in that way, and coffee has then herbal tea. This is of product type. Product type wise, they have sorted it, yes, but I don't want this product type. I just need only the product. So that the software, using a software, you can just click this one and remove it. So product wise you can sort it. Now you can have another interpretation. Now if I ask you a question, which graph will be a better one? See, both will provide a different interpretation. Here you can say coffee with Colombian coffee is the highest one, and you have only 3 category in that way, and which is other one, or other Irish and Amaretto coffee are very less sales in that way. So you can have more interpretation where the product type and the product, but here it is directly the product way, which are all more or less equally. Coffee latte and mint are consumed equally, irrespective of type of the product, you can compare it. So that is what the second graph is providing. So sometimes we need both of the interpretation. Fourth one is filtering, right? So filtering is act of data reduction, we can say, subset of the current view. So you see, if this is the view, I can go for a filtering or removing a particular view in that way. That is usually, for example, region and sales are given here. Suppose if you just check this graph where we have shirt, suit, pant, coats and shoe, I don't need this confusing one, the lines, or I need only the sales of suits. So that I have to click I have to click this one. So what happens, other lines won't be visible in the graph. This is what some of the interactive graph, one of the interactive graph we can say. If you just click the suits, other lines, all the red, orange and green, that is what coat, shoe, pant, and those lines will be vanished. Only this, the selected one will be there. This is what filtering, so that it provides you the clarity. So what happens, it is not deleted, it is for that particular instant you are filtering and viewing, that's all, right? Okay, so I will show you at the end of the session, I will show you the code and graph also, how to do the filtration and animation plots also, right? So in this way, see, this right side, all the plots and filtered views, shirt and pant only. Now the interpretation and comparison will be easy one, more or less in the same way, same trend both are having. So that is what the interpretation we can get. Next one is in filtration, you can have the radio buttons, where suppose if you are region wise, if you are showing, you can say all the regions or only northeast or southeast, in that way you can select. Or slide bar with the range, the sales, those who did 447 in the class sales in that way, or from a particular range 120 to only 190 in that way. So this is what slider you can use, or radio button. In this way also you can filter it. And then highlighting, there's another way of filtering, where in filter the rest of the information will be vanished. At that particular instant it will be deleted, but here highlighting, only the required information, which one you clicked it, actually the software will give you the clicking option or mouse over option, where the mouse is on the particular data. It is hover, HOVER, mouse hover point we call it as. So if your mouse over point on that particular data, only that will be highlighted. See here, it is actually number of purchases is x-axis, and I think age is actually, the age is, this is purchase amount is in y-axis, and age is given in the scatter plot. So whose age is actually a number of purchases in y-axis, sorry, age in the x-axis. Age, if you just check it out, I'm just checking less than 20, around 20 in that way. If you just check, all the red dots are around 20, that is what the age that way, right? Customer in the age 20s, they are purchasing less number of purchases because they are not in earning stage, so they are purchasing less. What else we can do with this highlight? See, more graph. As I said, you have to add the related items in a single graph in that way. So we have the subset of data in a multiple graph. At the same time, you can do it so that interpretation will be more there. Scatter plot, we have here the age group, right? And you can check this with this one. This is also age group where, see, all the graphs are related to the same graph, same data. If I select, when it is related and a single software is handling, if I select this less than 20 age and it is highlighted in red, all other graph also you will get the highlight. So your software should support such conditions. So whenever you are going for such softwares, you have to check with that whether this is available or not, that way, right? So if you just highlight one particular color, it should reflect. See, this particular graph is female and male, that is what the reflection in female. See, female less than 20 is higher than the male less than 20. Here also the purchase, here it is actually age group in this way. Here actually with the region wise, Boston, Los Angeles, New York, Seattle, in that way, region wise, so more or less equal in that way, right? So this is day wise here in that way. So at the end of the year, if you just check with us, all the 20 around age people, students, that is maybe student or in that case, right? So they are purchasing end of the year, where Thanksgiving or something else coming, they have more number of purchases. Why I'm saying Thanksgiving means because the data is about US data. So that's why. So at that particular duration, they have more purchase. Sixth one is aggregating. So aggregating and disaggregating, this is the level of viewing. Aggregation means higher level of summarization, combining. Disaggregation is lower level of detail, right? Separating and analyze in detail. That is what, right? So say for example, single product. See, instead of, for example, if you want to go for a product like how many jars of sauce sold, instead you go for the levels, group all the product of sausages, or you, or the region by group it, then count the sauce, the sales by the particular product in that way. A lower level means sales per individual product, individually focusing on the lower level, right? So sometimes a special aggregation will be there, where drilling or level of summarization will be moving on the hierarchical path in that way. So multi-level, where a total organization will be there, where it will be total organization, and next level will be the branches, next level will be individual shops in that way. Or else if you go for the whole country, instead then states, then district, in that way you can drill down. If you start from the whole country, then state, then district, it is drilling down higher to lower. And if you aggregate it from each and individual city to district, district to state, state to country, then it is aggregating in that way, drilling down. So drill up, drill down, both can be of special aggregation, you can say. Seventh one is re-expressing, where it is re-expressing in the sense, normally if you just check this first graph, the y-axis is in dollars, x-axis is having the software sales by type, where business, game, security, educational, right? The same data, if you just convert it into percentage, right, then you are just re-expressing the same data, but percentage means it will be, interpretation will be more useful one, right? The quantity, instead of just the dollar, if you use the percentage, the inference will be of a different one usually, right? And variations will be in dollar. Instead of variation in dollar, variation should be, or else you can mention it in this way. The lengthy 7 lakhs or 70 lakhs, you have, instead of using that, you can use it in this way. 7.5 in millions you can represent in this way with line graph. Why line graph? As I said, whenever x-axis is having time series, go for line graph. So the re-expression you can make in this way also. As I told you, it is monthly sales by comparing the January revenue. See, here where the deviation analysis, we fix the budget as 0. In that way, deviation is analysis. Here, January is the month. January month sales, say for example, if January's month sales is $10,000, so that is what we consider as 0. From 0, if you just check February, it is 50. That means 10,050. That is what the sales. In March, it is 150. So 10,150. Then April, it is here in negative 100. That means it is 900, less than 100 from January, in that way. So this is how, compared to a particular month, you can check the revenue. The same way, instead of representing it in USD, if you represent it in percentage, how the deviation is. Now the question is, which one you need? Both you need actually. The answer is, because here in terms of amount you can know, here in terms of percentage. That is, there is 1% increase in February, 1.5% increase in March, and there is a nearly 4% decrease in April. So this is what the interpretation. So both we need actually, right? Right. So this is a general trend through the time, that is moving average. It's a time series one, when moving average means the January and February, March will be considered as one particular average, and then again February, March, April. So the month will be moved, the averages will be one leaving one and taking the next one. In that way, we are calculating the moving average. This is just for trend analysis, we are using this moving average. Okay. Then revisualizing. So revisualize, how to see, this is what actual and budget expense. Yes, of course, this is a good bar graph where we have this gray color is budget, and black color is actual expense. And yes, of course, it is very good. But still, not we can't express, we can't interpret the difference between each, how much we have to compare with this, and what is this, and then what is the difference, right? Instead, if you use this in this way, what is the actual versus budget? See, the same data I'm using it here. This is also actual versus budget, but here budget is mentioned as 0. As I said, it is not the 0 budget. You can fix it as 1 lakh or 5 lakh or something. From that, how much differs for each and every month, right? This will be better. The ninth one is zooming and panning. So what do you mean by zooming and panning? See, this upper chart we have from January, 2 months of data of individual, each and every individual, where visitors of website and purchase. It's a e-commerce data where visitors and purchase are compared. Visit are more, the purchase is more. The trend is more or less equal in that way. But if you just check the whole 2 months data, you can't analyze the trend, whether upper trend or lower trend or adding and what. So in that case, you need the whole data also a part of data. That is why the option of zooming and panning is given. So just by a click or by selecting, it can be zoomed in this way. Say from February 14th, in this way, from this part actually. I will let me highlight highlight and show you from February 14, this point, right? And February 20th, this point. If you just check this point here, right, how zigzag it is. But if you zoom and check, you can have the trend here, which one is higher and which one is lower. And here, if you just check, it is more or less in 18 and 19, it is more or less equal, right? But 18, we have a difference between visitor and purchase. 19, it is same. And 20, it is also both the same. Only then, right? So zooming and panning will give you more idea about a particular part of the graph, right? Right. 10th one is rescaling. Scaling and rescaling is whenever you have such amount of USDs, or you have, it is better to use a scale value, log scale value, or the common scale value, where the base value into 1 in that way. So it is each value of the previous interval into base value. That is, value of the previous interval is 1, the base value is 10 in that way, right? So actual value is 110, but logarithmic value what you are using is 0, 1 in that way. So it is better to have rescaling whenever you have such a large number of data in y-axis. That is volume of data. The length of the data is higher one, right? And now if you just check, it is rescaling is not also for the visualization purpose. It is, rescaling is very much necessary whenever you are going for rate of change analysis. Rate of change in the sense where this orange color, it represents the software and the blue color represents the hardware. You may think that hardware is higher one, right? When it is directly used, y-axis has USD, it is higher one. Yes, of course I accept. But if you want to analyze rate of change, it should not be in direct amount. Instead, you have to use this scaling, log scale, or some other scaling value. Now if you just check, both are in the same rate of change. There is no change in software, right? So now interpretation is different from, right? If you just check this one, y and log y, so taking a logarithmic y, right? This is what normally when I use in the y-axis, normally I used only the direct value, how the y is, and when I change this into log, how the difference is. Now I can see there is no difference, much difference between 3 and other values. If you use log y, you can compare the rate of change, right? So now I'm going to show you some of the coding part, right? So that let me stop here and share this some of my tabs. Till now, any doubt? Before moving on to the EDA part of coding.
Participants.
Okay.
Any questions? No questions. We can move.
Yes, ma'am. Right. So right. Hope the screen is visible now. I have shared one of the collab Python EDA for right. I will take, okay, indicator label. Yes, it's about, yes. Let me start with this one. This is about explore EDA for a milk production actually. right? It is they have taken the district in Tamil Nadu and they have analyzed the production actually of the district wise milk production, and it is it gives the names of each and every. It is this is just a sample of the data what we have taken. It is the sample can be viewed with df dot head, and then whether it is any null values are there or not, it can be analyzed by using this print df is null checking, and then the describe function will give you some of the related items to that. But before that, let me go with the graphical representation instead of this statistical one. Yes, they have used some of the statistics also, melting and those things. See, if you just go for the description of the count, mean, standard deviation, minimum, 25%, 50%, the quartiles, percentiles, what I explained you, all are given here this way, right? And then, so here we have a bar plot. This is will be interesting one to you because the y-axis contains a district here, and x-axis contains the production, and here starting with 2009 and ending with 2018. This is not a normal graph, it's an interactive graph. Whenever the mouse over that particular bar, it will give you the information where district is Salem, and year 2009 the production is 479. Right, some it will be like it will be ton or something like that, it will be there. So if I just click this one, this is, if you have this particular option here when in graph, that means it is a animated graph. See how the animation they have added it. It is just the number values. When the year is increasing, you can see the year is increasing. When I click that 2009, 2010, see it is moving, right? The progress bar is moving, and according to that you will have the amount here, right, in that way. So you can also have this zoom option, what I told, the highlight option. See, I can only highlight where other bars are not visible, only this is visible, highlight that way, right? We can have such option also here. See, this is what I said, the highest one will be always in the top way horizontal view. And if I do this here also, they have added, this is done by the student, I'm just showing it to you. So see how the animation is they have done from 2009 to 2018, how the production changes in this way, district wise, of course, that way. And this is just the dot graph. When you may have that more number of dots in a particular graph will get a confusion. Suppose if you add an interactive graph in this way, and with the mouse over that particular point, you can get the information in that way. And this is what I told you about, a more number of lines will be there. If I want to go with a single one, single select or a zoom one, you can do it, right? See, if I want to zoom only this particular point, see, only that particular 2007 and 2000.1, in that way I can zoom it, right? Zoom in, zoom out, and the pan, everything is available here in that way. And yes, this is about heat map. Usually heat map is used for correlation analysis, where correlation will be -1 to +1 normally. And so here if you just check this, instead of correlation analysis, what they have done is, it is just the production is mentioned in a heat map, where this bar will give you the number of production is less means it's a light color, and then more means it is a dark color. In that way they have mentioned the production, right, per year wise production, that way. Yes, and this is box plot. As I showed you, here you have this 25th quartile, 75th quartile, and also this medium, and these lines are what we call whisker. These lines are, we call it as whisker point, and This, if you just mouse over that particular box, it will give you everything. Upper fence, what we calculated in the previous session, upper limit, lower limit, that lower fence, upper fence, minimum, maximum, Q3, Q1, Q4, everything is visible here, right? That way. And these dots are nothing but the same data points. For this data point, this is actually the box plot. Both can be represented in a single graph in that way. And this is also a box plot. This is another way they represented it. Instead of different colors, they have used it as a violin plot. But though if you just check this function is violin plot, though the violin is not visible, I will show you with another data, the same violin plot. And this is sunburst plot. This is a very interesting animated plot, where if I want to see from here, you can check this one. Okay, 2008 the production is more, okay, of course, but 2009, the 2018 higher, but 2009 is very less. Or you can see whenever as the year moves on, the production is increasing. That is another interpretation, right? What about the district? What about the outer line? So if I just click one particular graph, one particular year, all the district in that particular year, the sales will be visible. Now if I go with the mouse over point, it will tell you all the information about district production, cumulative production, everything, right? That way. This is what sunburst. If I click it again, it will go on. Suppose if I want to go for 2015, click it again, you will get the one, right? That way. So now this is actually a tree map, where highest one will be in the upper one. It's a box plot. We won't say it as a box plot. It's a tree. That hierarchical order, higher value will be in the upper left top, and lower will be that is less or less count, or lowest will be in the lower right corner. In this way, this is what we call tree map, another visualization. And this actually region wise, they have mentioned in which region, which district are included, and how much production in this way, right? This is actually the name of this is actually network diagram actually. So which is a different one. I am going to focus only on that one. Yes, this is what we call it as Pareto chart, where bar graph will be there. Along with the bar graph, we will be having a cumulative production line, where if you just check this one, this is 9K on in 2009, and then in 2010, this particular point indicates 2009 plus 2010. And in the same way, if you just check this line in the 2014, the orange line, it indicates from 2009 to 2014 what is the production in that way. Especially whenever the sales data is shown, when the particular target is reached, on which month is reached, we go for this Pareto chart. The name of the chart is Pareto chart. And yes, of course, you can go for the spatial graph also, where if you have the latitude and longitude, we can go for this spatial analysis graph. That is also possible. With mouse over point, it will tell you which one is which particular district is producing more. This is what the deviation I told you. See, it is from improvement, right? There is an improvement. Trichurapalli has improvement, Salem has improved, and which district are actually deviating. It's decreasing from the particular point, right? You can set the particular point, and then whether lagging, positive means above, and lagging behind the budget, behind the objective, is actually this one, the orange district, in this way. This is what deviation graph I explained, right? In the same way. So deviation with the legend, you can have the heat map like a thing. You can have the color code also in that way, right? And yes, okay, let me go for some other data so that you will get more information. In this way, see, whenever you are going to show the related item, you can show it in this particular way. What is the trend, which district is, which are the top 5 district, or in that way, what is the growth rate distribution. In that way you can explain this. Okay, so yes, in the production they have the gold, silver, bronze also, in which year, a particular year, how much gold, silver has earned, in that way, right? Let me go with another one where, this is another data. This is about yes. They have used the interpolation method, as I explained you about interpolation, the median they have used. And this is about trade in services. It's about GDP and everything they have analyzed here. We will see which particular, what are all the different frequency. These are all just the line graph, time series 1. And the related items are, as I said, the related items are added in that way. Yes, this is about deviation graph. When the percentage of GDP is increasing or decreasing, the deviation. And it's not deviation. The upper one is greens or China, and the lower or India, in that way you can see. And I will show you. Yes, here we have this animated plot where 10-year annual growth rate. If I just click this here, you can see the growth rate, or whether about China and India, how the growth rate is increasing. GDP per capita, FDI flows, and everything, right? This is another animated graph. And of course, this is a heat map, the correlation, as I said. So the correlation usually is symmetric. Upper diagonal and lower diagonal will be same. It is not necessary you have to have all the full matrix. Either lower or upper you can use it. Usually for visualization, that will be better whenever you go for research paper publication and all. So either upper or lower you can use it. And yes, combining it. Sometimes it is better to represent it as a table instead of always going for a graph one. In table you can show, like with the colors you can show the difference. And this is a donut chart. We call this as donut chart, and this is dot chart. And here this is spider. Actually, I will show one more, another spider, a better one. Yes. And let me, this is about a credit card, actually payment data. Sorry, I'm just speeding up because of the time constraint. This is actually a violin plot. I told you box plot or violin. What is the difference between box and the violin plot is, in violin plot, with that outer line, it won't be like a box. Based on the number of data on that particular point, it will be either bulkier or slim one, in that way. That is what, in violin plot will give you more interpretation than a box plot. That is what the usage of violin plot. See, box will be straight, violin will be a different one, right? That way. This is all distribution plot, where this is more or less bell-shaped Gaussian distribution, where we have the multi-model distribution. Multi-model means two per one, two peaks will be there here in the distribution. That is what multi-model. And this is another important graph. It's a interesting graph rather. Stem and leaf plot. This 1, 2, 3, 4, 5, 6 here, right? In this particular line, this 1, 2, 3, 4, 5, 6, 7 are stem, and these are all 8 leaf. What do you mean by that? This is actually the whole data. where the age starts with 18. How will you know that it is 18? You have to take this as a 10 plus 8, 18. And what is the maximum age in that company or in that credit card they have issued? 74. 4 is the last one, 74. In that way, you have to go interpret the stem and leaf plot. The stem and leaf plot can also be interpreted as histogram plot because it's just the frequency that way. So, yeah. Yes, it is with the set graph also you can have. This is what we have, scatter plot. Some scatter matrix plot where as I said, a scatter matrix mean upper and lower diagonal will be same here also. This diagonal will give you the distribution plot, and this other plot, other point, other matrix way, you see, if you just check this one, account tenure and age, that is what the distribution x and y, right? Diagonal will be with the same only age, what is that, or account tenure. In that way you will have the diagonal one that way. Okay, then heat plot we have is, these are all distribution, actually box plot and the bar plot. Yes, this is violin plot, interactive, board, violin and box is given, interactive plot. Spatial analysis, you can have it here. Yes, this is actually the spider plot where this credit score is given here and credit utilization and debt income ratio is more, and this indicates the level, actually delinquent level, in that way, right? This is about spider plot. This again, this is tree map, and this is a 3D plot. As I told, 3D plot, you can have a zoom and pan here in this way, and a particular point you can access and get more information. If you have this animated option, you can use this animated option for 3D. Otherwise, no, don't go for a 3D plot. Right. The next one is about gold price. I will tell you if it is anything is different from other than what we have explored till now. This is actually lollipop plot, where again it is represented using the correlation. The correlation, no need to go for always go for heat map. You can use this correlation with a deviation graph. Negative correlation will be in a downside, positive will be in upper side with lollipop plot. Yes, and this is distributions. See what type of distribution, kurtosis, skewness also you can visualize here. Yes, we have outlier. The box plot will tell you for any box plot above or below the whisker, above whisker or below whisker, whatever the points here, these are all outliers actually, right? That is what we actually calculated in the previous session. And this is another spider plot where we can say average monthly price change. In August, the price changes till 15 actually, 2.55. This interest rate in every month. In that way, gold, sorry, not interest, it's a gold rate in every month, how it varies actually. Which month is greater? The spider plot will be the same way. If you just check the for a whole in a particular day, particular week, what is the web traffic, if you analyze, you can go for a spider in that way. So time series based web traffic also we can go for spider graph. Yes, what else we have? Again, this is a 3D graph. You can zoom and pan and check. Yes, and this is finally, you have an option of PyGWalker package in Python. So I have just executed this PyGWalker with, I have given a data set so that your own visualization, that is just like visualization task, you can create. See, this is just the data what I have loaded here. See, the data is, it's just the import PyGWalker you have to do and execute. Then I have loaded the CSV file here in this line, right? And this is actually the data we have. So it's a data about season, hour, year, temperature, humidity, wind speed, and those things are given, right? So if I execute this PyGWalker DF, right, you can get a visualization. You can create your own visualization toolbar for this. And how it is working, it just like Tableau or Power BI, just like any other visualization tool, it is working. It is suppose if I want to know the hour wise temperature, in this way x and y axis I can show it. And again, what is the humidity, I just make it with the size of humidity I have to see. I'm just dragging and dropping here. And what about wind speed, I'm just opacity, I'm just explaining it, what is the wind speed in this way. And color, I'm just that is casual in that way, color. And then count, I can use the shape of the count in that. So you can have your own dashboard also using this PyGWalker. Yes. Any doubts or any questions you have? That's all the sessions.
Participants.
Madam, good evening, madam. Hello.
Yeah, good evening, sir. Tell me, sir.
Madam, if more number of outliers present in a box plot, does it make any sense, madam?
Yes, sir. Suppose in what purpose you are analyzing the data, based on that the outlier sensitivity will differ, sir. Suppose if you want to just have an analysis only, that it is you have more data in the outlier, you can represent it. Yes, this many data among this, say for example, among 1000 data, 200 are outlier in that way. But the same outlier data, if you want to go for a machine learning model or something else, it is better to have separate model with outliers. Just separate the 200 data, create a separate model, remaining 800 data, separate model, and go with the analysis. So in what purpose you are going for analysis, outlier analysis, based on that it differs.
Okay, madam. Madam, somewhere you shown some neural networks like plots, madam. What is that?
Yeah,
madam?
that is spider plot.
Okay.
It's usually a spider plot. It is we used time series 1. I will check with another example and I'll show you that. Wait a minute. Because a spider plot is not visible in the coding, I'll give you that. Wait a minute. Yes. I have a good example of internet connectivity data. Yes, this one. I'll just, yeah, I'll share you it. Yes, this data actually, this is again a spider radar graph or spider graph. We can mention it in any way. See, the lines indicates 4 days actually. And here this indicates from AM to PM, from a whole day, a day is indicated. And here this particular part, if you just mention this, wait a minute, I'll mark it. Right, this one, see, the lines here in each and every line is indicating hours actually, sorry, a count. So when you, if you just check it on early morning, it is only 50,000 people are using it all the days. When it moves on to this one, so it in between 11 to 12 it is increasing actually. See, early mornings 6 to 7 a.m. it is very less, then increasingly it is increasing. At noon we are many of us are using this websites, right? And then again in the night it is reducing in that way. So AM to PM is indicated in circle, right? The count is indicated in between points, and the line indicated the days this way. So if you have a data in this way, you can do the analysis.
Madam, it is changing from the origin to when it is moving end.
Yes, yes. Origin is zero count. Then end, it is 2 lakh people are actually using this.
Okay.
2 lakh is the maximum, but at the day, if
I
you
think
just
each
check,
and every line is also, I mean, differ in length also. Okay, when it is looking horizontally, I mean, latitude wise, it is a little more lengthy. That
yes, that is in daytime they are using more on all the time. And this graph is also explaining one more thing. It shows you the cycle of the time graph.
okay.
Because usually time series we call it as seasonal and cycle, right? This is cycle actually. Every day the same cycle is repeating that way.
One more question.
Yes, sir.
Actually, we have nominal, ordinal.
Yes.
So, which sort of techniques can be used for which type, man, for representing the data?
Whenever you are going for ordinal one, you can represent it that is nominal one, you can represent it anyway. That is what I showed you, north, west, east, south. You can represent, but ordinal means either in ascending order or descending order you have to follow. Which one is lower to higher or higher to lower? Either it is a bar graph or any graph, you have to, usually a bar graph will be used for any such data. So you have to use it in either ascending order or descending order.
Madam, somewhere you shown the heat maps. That is the
Yes, sir.
intensity which indicates the level of level.
Yes, sir. Yes, sir.
So
Yes, sir.
at a time, how many number of elements we can take it, madam, vertically or horizontally?
See, it is based on the shade what you are using actually. So usually the correlation graph can be used three colors, where the intensity is very low, one color, zero, one color, and highest, more color. So usually correlation heat map is most of the time we are using for correlation, where 1 is the highest one, -1 is the lowest one, 0 is the no correlation. That way. So based on the intensity, the level will vary. Either a 2 color or 3 color usually they use.
Okay. Thank you, madam. Thank you very much. Nice.
Yes, sir.
Any other questions? Ma'am? Participants? I think it's over. Shall we wind up the session, ma'am?
Yes, ma'am. Yes, ma'am. Thank you, ma'am. Thank you.
And thank you very much, ma'am, for your wonderful presentation. In the future, if it is possible, we will arrange one hands-on training in this session, ma'am. It's really very wonderful and informative session. Thank you all.
Okay,
Thank
sure.
you.
Yeah.
We'll post the link here and WhatsApp group also for both feedback and questionnaire session.
Hello. Yes, ma'am. I will share, ma'am.
பால் நல்ல பால்